Hi, in this video, I would like to introduce you to exponential notation. Let's look at a familiar example here. Here I have an arithmetic expression, 10 added to itself. I took 5 copies of 10 and I added them to each other. Now I know you want to say this arithmetic expression evaluates to 50. And you're correct, but right now my focus is not so much in evaluating what this arithmetic expression is, but in fact bringing to your attention that there is another way of writing this long expression, 10 plus 10 plus 10 plus 10 plus 10. A shorthand notation is 5 times 10. In fact, the multiplication notation helps us write this expression 5 times 10, which is by definition exactly this long expression that you see out here. So in other words, 5 times 10, you can think of it as an abbreviation for writing 10 plus 10 plus 10 plus 10 plus 10, which is pretty long. Now look at this example. Here we are multiplying 10 by itself. And how many of those tens have we taken? I've taken 5 times 10 tens, and I'm doing 10 times 10 times 10 times 10 times 10. So this is a very long arithmetic expression. Yes, I do know you can multiply and obtain an answer for this expression. Once again, my focus is on bringing to your attention there is a shorthand way of writing this long expression. If you stare at this expression, as you can see, it's kind of hard to read. 10 times 10 times 10 times 10 times 10. You just want to tell somebody you're multiplying 10 by itself 5 times. And here's the exponential notation I want to introduce you to. We write 10 here, 10, and then up here we put how many of our copies that you multiplied them by themselves. Here it's 5, 10 to the 5. So I want you to remember 10 to the 5 is a shorthand notation for this long expression. So 10 to the 5 written, and this is written as read as 10 to the 5 or 10 raised to the power of 5, or it's okay to simply say 10 to the 5, and when we say 10 to the 5, that is simply an abbreviation for this long expression. So keep that in mind as we look at more examples and applications of this exponential notation. So let's look at what I have here. Suppose A is a number. What do I have here? I'm adding A to itself and 18 copies of that. As you can see, I don't have the patience to write out A plus A plus A, 18 of them. So this is one way of handling that. All right, A plus A plus, I put dot dot dot. That means that pattern of adding A continues, end it with plus A. I can write here 18 copies. So that is that. So this expression written like this with dot 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 means A added to itself, 18 copies of them added to itself. Now there's also a shorthand notation for this exact same expression. By the definition of multiplication, this expression 18 times A is simply 18 copies of A added to themselves. Exactly this expression. So this expression is exactly same as 18 times A. Furthermore, it is an understanding, an agreement in mathematics that when we have 18 times A, we simply choose not to write this multiplication sign, and we simply write 18 and then the letter A. The letter A, it is a number. We simply write it as 18A, and the understanding is that 18A means 18 times A. And once again, 18 times A is simply a shorthand notation for 18 copies of A added to themselves like this. So this is something you're pretty familiar with, I hope. Now let's look at this expression. Here I have A multiplied by itself, and I would like 18 of those A's multiplying themselves. As you can see, I do not wish to write all of the A's. So that's why I use this dot dot dot. I write a few of them, put it times, put dot 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 another times, and then end it with an A. And I write here 18 times. This is a very long expression. And as we've discussed before, we have an exponential notation to write a shorthand way of writing this, which is simply this. We can a, the number that you get keeps getting multiplied. I write it there. How many of them? How many times? 18. The 18 goes up here. We can read it as a raised to the power of 18, or simply a to the 18. A to the 18 is simply a shorthand notation for this very long expression. And here's some vocabulary for you to remember. In this expression, a to the 18, this number a is called the base number, and this number that you see in the power or the exponent, that is 18, is called the exponent. So keep this in mind as we work more with exponents. So let's summarize the discussion with a precise definition. Suppose a is a number and n is a positive integer. So a can be any number, so that means any point on the number line. So for us, it's you can think of a as any whole number or any fraction. And whereas n is a positive integer, so n could take on the value of 1 or 2 or 3 or 4 and so on. And by definition, whenever we write a to the n, so whenever we have a number here raised to an exponent that's either a 1 or a 2 or a 3 or a 4, you get the picture. The exponent is a positive integer. The base number is any number, most likely for you either a whole number or a fraction. So when we write this, you should remember this is simply a shorthand notation for this very long expression where a to the n means a is multiplied by itself and there are n of those a's multiplied by themselves. So remember here, since I don't know what a is, since I don't know what n is, I don't really know how many a's to put actually. So that's why I use this dot 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 notation. You see the pattern. I'm multiplying a by itself times. I'm continuing to do that. That's what this dot 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 means. And with times a, and underneath write like this n times, and that will be clear. So take the time to practice this notation and this definition, and in the next few videos we'll use this definition and we'll work with it some more. Thank you.